Good morning everyone. Welcome to the next lecture. Today we are going to see Mechele's method. So Mechele's method is a little bit advantageous method than double integration method. You can see it is advanced and modified double integration method. So the same procedure is being followed for Mechele's method also as like double integration method. The same steps will be followed. But what are all the limitations? We have seen that double integration method cannot be analyzed when there is more than one load, or when I is changing or E is changing. But in this case we can adopt any of this case by changing only one step. So let's see with an example. So example number 1, it is a simply supported beam with 50 kilonewton at 1 meter from the left support and 40 kilonewton from the right support. So first step is to find out RA and RB, that is support reaction. So support reaction is to be found out only for the simply supported beam. Then second step, so with this moment about A equal to 0, then finding out, you can find that RB is 34 kilonewton and RA is 56 kilonewton by substituting summation of moment about A equal to 0 and summation of vertical forces equal to 0. Then step 2 is taking moment about X. So this is the step in which you need a little more difference, because in this problem you can see there is 2 point loads, that is it has more than one load. So here you can see that you will have 3 moments, that is you have to take AC as one segment, CD as another segment and DB as another segment. So you have 3 segments and you will have 3 types of moment. So MX, so first section is between A and C, that is in the first segment. Then what will be the moment? RA into X. So here the section is at a distance of X from the left support. So first moment is RA into X. So here 56X. Then for the second moment at the middle section, so here when the section is, so you have to mention the same X, not X1 and X2, the same X value. Now the moment is RA into distance X minus 50, this is 50 kilonewton, minus 50 into X minus 1. You can see here at this section, here there is X up to this distance, it is X from A. So A to C is 1 meter, so it is X minus 1 meter, that will be the distance between C and X. So minus 50 into X minus 1. Then at the third section, now you cannot take the left side, as you travel from the left side, the X is the distance from A, so you have to take all the left side forces only. So moment about the third section, then RA into X, you can see it is RA, the distance is X, and then it is minus 50 into X minus 1. You can see this is minus 50 into X minus 1. You can see this full distance is X, and you can see that it is only 1 meter. This is 1 meter for the first segment. You have to subtract that, so you will get this distance, that is from the 50 kilonewton, and the distance X is X minus 1. Then 40, this is 40 into the total distance is X from A, and from this 40 the small distances you have to subtract this 1 and you have to subtract this 2. You can see that here it is 2 meter and 1 meter, you have to subtract 3 meters. So 40 into X minus 3. So this is the moment. So now you have 3 moments. So these 3 moments should be written as a single equation. You can see that this RA into X repeats same in this 3, and then this minus 50 into X minus 1 is also here. The only change is one extra parameters are coming. So combining these 3, you can see that MX is first 56 into X. This is for segment AC only, that is when X is equal to 0 to 1, you have to use this thing, that is only 56 into x. Then you have to draw a dotted line mentioning that it is second segment. So this equation so from 0 till this total segment, you have to use these two equations, that is from x is equal to 1 to x is equal to 3. Then combining with the third segment, so this 1, 2 and 3 equations will be there for this third segment, that is from x is equal to 3 to x is equal to 5. So moment varies with x values, that is from x is 0 to 1, it is only 56 into x. Then x is equal to 1 to 3, then these two things will combine. Then for x is equal to 3 to 5, then this three parameters will come, all the three parameters will come here. Then as usual, the other steps are similar to the double integration. After finding the moment, substituting in the dy by dx, and then substituting in the moment in the differential equation, you can find out that then integrate the values, then integrate the equation by substituting the mx value. You can see that you can cross multiply the ei on the other side, and then you can write the equation here and then integrate it once. So you can write the constant c1 in the first case only, because if x is equal to 0, you have to use only one segment, so c1 should be here only, not here and not here. So c1 only in one place, because this is the whole one equation, so only one c1. Then again integrating it, you will have c1 and c2. So this is equation 1 and equation 2. After that, applying the boundary condition. So here x is equal to 0 and y is equal to 0, that is at point a, when that is x is equal to 0, y is also 0. Then x is equal to 5, that is at the last end, that is at the b, because 2 plus 2 plus 1, so totally it will be 5 meters. So at b, y equal to 0, because in Mechele's method, for simply supported, you will have a small change in simply supported boundary condition, that when x is equal to L, the y equal to 0. But for double integration, you have to use x is equal to L by 2 dy by dx equal to 0, but here it will be changing. So you have to apply this boundary condition equation 1 and 2, so that you will get c2 as 0 here and c1. So you can see that for x is equal to 0, y equal to 0. So in this equation, if x is equal to 0, you have to use only this segment, that is only first segment. So till only this you have to take the equation. Then what it will be, x is equal to 0 here and x is equal to 0, only c2 will be there. So c2 is equal to, here y is also 0, so equal to 0. But for the second case, that is second boundary condition, x is equal to 5, y equal to 0. When x is equal to 5, you have to use all the three combined, because it is in the third segment. When x is equal to 5, it is a third segment. So substituting all the values, that is x is equal to 5 in the y equation, so you will get c1 value as 283.3. Then substitute the c1 and c2 value to get the modified slope equation and modified deflection equation. Then now we have to find out the slope and deflection at different points. So here the slope is given at a and slope given at b. You can see that at a only the first segment is applied, and for b, that is x is equal to 5, all the three segments are applied. So here a little bit conversion is required. You can see that till here you have substituted the load as kilonewton. The load is kilonewton and the moment is kilonewton meter, but you have E value and I value in Newton per mm square and I in mm power 4. So conversion of meters to kilonewton, you have to convert the numerator. For this is only for the slope. To convert kilonewton meter square, it is 10 cube into 10 power 6. You have to multiply here. and then substitute the E and I value in Newton per mm square and I in mm power 4. So conversion is 10 power 3 into 10 power 6. So total this slope unit is, it is radians. Then slope at B. So here also the same thing, after substituting you will get this value. Then for deflection, so here for the deflection you are integrating the slope, correct? So you have to multiply another one meter to millimeter conversion. So you can see that the conversion of the numerator for deflection is 10 power 3 into 10 power 9, 10 power 3 into 10 power 9. So all other than all the substitution is same. So here x is equal to 1, that is you are finding at the point load, exactly at the point load. So y at C, you can see in the question. So at C, exactly under the point load, you have to find out the y value. Slope you have to find out in A and B. This y value should be in C and D. For this, if they ask for the maximum bending moment, sorry, maximum deflection, then maximum deflection will be always at L by 2 distance. Maximum deflection will be always in L by 2. Okay. Then so finally you have substitute the values and you have to think. But here you can still you have to remember that for deflection you have to multiply 10 power 3 into 10 power 9, but for slope you have to multiply by 10 power 3 into 10 power 3 into 10 power 6. You have to remember again and again. For slope 10 power 3 into 10 power 6, for deflection 10 power 3 into 10 power 9 has to match kilonewton meter towards Newton millimeters. So by this Michaelis method is been understood, because Michaelis and double integration both are the same way. Only thing is that this moment and dotted lines is the additional thing in Michaelis method, so that you can use more loads in a single thing. That is, you are dividing it into different segments. If you are not dividing into segments, then it is called as double integration method. Thank you.